So with log graphs and exponential graphs, the whole idea is to remember they work hand in hand. If you're given a log graph, its inverse is an exponential graph. If you're given an exponential graph, its inverse is a log graph. It doesn't matter where you're coming from. They just go hand in hand. So with this equation, right, what you want to recognize is, you see, you have y equal to log half with x there. There's a base. This value here, we consider it the base of your log. It's just weird. You don't want to think of it as a base and an exponent. No, it's just the base of the log. Because remember, in your calculator, there are two log buttons. The first one is just log, and it doesn't show anything here. That's because by default, the number there is a 10. And then the other log button has two things. There's one thing here, one thing there, you see. So this here is always considered the base of the log. Okay. Now, all that being said, right, when it says determine the equation of the inverse of each of the following functions and then sketch the function and its inverse in the same set of x's. So the fortunate thing is, this is one thing you can really lean on. So when you're saying what you're saying in the beginning, it's okay for you to feel however you're feeling, right? But this is one thing you actually want to get in your head also, so that you can take advantage of it. Inverse is actually one of the easiest topics in your grade 12 math. I'm not trying to say you're going to get topics that are like hard or whatever that will make inverse look easy. No, I just mean without, let's say, feeling too clouded, or the moment your head is in like a very good space, some of this will also start to like click. But here's why I'm saying the things that I'm saying. With inverse functions, remember, firstly, you will work with, you will actually, I don't think you guys actually work with hyperbola when you deal with inverse functions. Yeah, I think you only work with what is this? With what's that thing, man? With the parabola, straight line. Let me see here. Straight line, and then lastly exponential graph. Now here's the good part. When you work with an exponential graph and a parabola, firstly, with the parabola, it will always be grounded at the turning point will always be the origin. Okay, no, actually, yeah, it is. I think with grade 12, it's always the origin. Literally, always the origin. So that's already a big advantage. You can just even look at these questions. This, the turning point is at the origin. This, the turning point is at the origin. Like, we know it. Because if you look at this equation, the equation of a parabola, it's y minus, there's a here, right? And then y minus p squared plus q. Now, if you look at it nicely, this is like y is equal to a is the 2 there. And then there's nothing directly next to x. So you can see it's like minus 0 there. There's nothing on the far right. So it's also a 0 there. So the turning point is 0, coordinate 0. Same with this down there. You see, y is equal to negative a half x minus 0 squared plus 0. You see, the turning point is just 0, coordinate 0. So that's one thing you can lean on forever. And then it also just means that with your parabolas, I mean, it's easy to work with. So with a straight line, also it will never be anything crazy. So with an exponential graph, what I'm trying to say here is that it will also always be a basic exponential graph. It won't be like moved up and down, blah, blah, blah. They'll always try to keep it basic. And just these examples what should help you. See, this is an exponential graph. You can see it's a basic exponential graph. Same here, super basic. There is no asymptote there. That is not a 0. You see, the asymptote here is a 0. So you just want to rest knowing that, wait a minute, with inverse, it's actually going to be a matter of just working with basic functions. So since here we're dealing with 9, right? They want us to get the inverse of this log, and they want us to sketch it also. So the issue is that, remember, with inverse, x becomes y becomes x. So what that looks like is, when we have performed inverse here, Where this y is, you're going to see an x. Where this x is, you're going to see a y. You see. Now the issue is to just make y the subject of the formula. Now the easiest way to do it is to remember that this is the base of the log, but it is also the base. Or remember, we said a log graph, its inverse will always be an exponential graph, and an exponential graph has a base and an exponent. You see. Now all you want to remember is that this will always be the base, and the number on the other side will always be exponent. You see, base, exponent. As long as you can have this as the base, this as the exponent, you're good to go, because y is the one that's supposed to be on its own. You see, so you're going to have your y is equal to the base to the power of the exponent. You see, that's it. You have performed log here, and this you have just made y the subject of the formula. Does that make sense?
Yeah.
Perfect. Now comes the second half of the question. They want us to draw the graph and show the line of symmetry. So if we're going to draw the graph, we need, what do we need? We need a Cartesian plane. So let's see here. We have this, and then we have this. So the easiest thing to put there is our line of symmetry, right? So let's just throw that there. Just throw that there. Throw that there. Perfect. Wait. There we go. So with all that we are doing now, the next, this line, oopsie. The next thing you want to remember is that with sketching graphs that are inverses of each other, it's always something that is very standard. You hardly ever have questions that are over the top. Now this is what I mean. Firstly, you may instead of usually when you're dealing with things like this, right? Because we have worked more often with an exponential graph, you want to draw that one first, because drawing the inverse is always easier if you have the line of symmetry. So you have your line of symmetry, you can label it. It's just y is equal to x, right? Perfect.
Lima, will it always go that way?
Always, because this is y is equal to x. This is saying that the coordinates on this dotted line, the x values will always be equal to the y values, you see. So if this is like a 1, this will be a 1. If this is like a 5, this will have to be a 5. If this here is like a -3, this will have to be a -3. You see, the coordinates on this line, they are all always going to be exactly identical. So if you have y values here that are negative, the x values will also be a negative. If you have x values here that are positive, the y values will also be a positive. So yes, the easiest way to answer your question is to say yes.
Okay.
It'll always be a positive line with a positive gradient, and the x values will always be equal to the y values. Hence the equation y is equal to x, because this is just saying it's a straight line, the gradient is a 1, and the y-intercept is a 0. You see?
Yeah.
Yeah, we just draw it as a dotted line so that we can just see it's a line of symmetry. It's not like a line that exists. It's just there for us to see it, what you call an image of how the two lines work together. They are reflections of each other. One will be on this portion of the image, the other one will be here. Or you'll just see how it will be a reflection of each other about this line here. So firstly, with drawing the equation of the exponential graph, we said it's usually easier for you to do that first before you worry about the log graph, because the log graph is not common to us. And we also, it's not something that you go deep into in grade 12. The only time you're going to see a log graph is if you're dealing with inverse functions, like literally, that's it. You don't need to worry too much about getting too deep into it and log laws, and it's just usually very unnecessary. So here, drawing this graph, right, all you need here is just to visualize this image. So remember, you have the x-axis here and the y-axis. You just want to know that firstly the asymptote is just 0. Y is equal to 0. So you know the asymptote is here.
Yeah.
Now you can see logically here, if your x values are getting higher and higher and higher and higher and higher, the value of exponent is going to get less and less. What I mean is you can even just check with your calculator also, just how x values are going to be affecting your value of y. Let me just write this a bit better so that it's like, you know, normal to look at, because it's looking a bit weird. So here y is equal to a half to the power of x. So if you put an x value of let's say 0 here, right?
Mm.
Your
Get
y value is
1.
going to be a 1. Now, if you keep putting positive x values, your number here is going to get smaller and smaller and smaller.
Yeah.
So you
Okay.
already know on the left side, it's going to be getting smaller. But then if you put like negative numbers here, the value of your whole number here is going to be getting bigger and bigger and bigger and bigger and bigger. So you already know that on the left, your picture looks like this. And then on the right, your picture looks like this. You see? So as long as you can draw this picture, drawing the inverse is a bit easier. And here's why. This is all you do when you need to draw the inverse. You just need to make use of your line of symmetry. Your line of symmetry is all you need. And this is what I mean. Your line of symmetry is what tells you that, okay, this is a line of symmetry, meaning what you see over here. If you go straight down along, if you see, remember with the line of symmetry, it's all about using it to see the image on this other side. Because you see, you have an image on this side of your sketch, and then you have an image here also. So all that happens is with your inverse, what you see over here, right? You can see here, what you see over here, all the way until your line of symmetry here, you should have this same picture reflecting on this side. You see, now this is what I usually do. Always just focus on the arrows, because if you focus on the arrows, right, this is what you will have. You have here an arrow over there. Now, the distance from here to your line of symmetry should be the same as the distance from your line of symmetry on the other side. So if you have an arrow over here, the arrow of the inverse would be somewhere here. You see, can you see? You have an arrow there. So a reflection of it should be there. Do you see?
Yeah.
Yeah. So let me make our sketch bigger also so that I have some space to lay out what I need to lay out, so that we don't like seem as though we are limited, because we are not. So with that being said, the other portion of the sketch, same idea. You see there's an arrow here. You can see that the small distance here, it should be the small distance on the other side. So you have an arrow over there. You see?
Yeah.
Now, both graphs will always need to pass each other at the line of symmetry. If one line is passing the line of symmetry, the other one has to pass it as well. And I kind of, I see here, I left out this line. Oopsie. Oops. Let's do that. Yeah. So let me repeat. This original graph is passing the line of symmetry. So our inverse should also pass the line of symmetry. So your image will look something like, let me just draw it nicely. We had an arrow somewhere here, right? So we would have something like this. Or rather, you can just use it as like a way to refer and see how your sketch would look. So we know our arrow was supposed to be somewhere here. So this would be good enough. There's arrow there, arrow there. And you can see if you look at it along the line of symmetry, on the line of symmetry, the image you're seeing here, the reflection is over here. Do you see that?
Yeah.
Yeah. And that's how you work with your line of symmetry. And that's how you draw your inverse functions, you see. So what we do know is, according to our question, this was g of x, right? So g of x, remember, it's the log graph. And then the inverse was this one, which we drew first, because we said it's easier to work with what's normal or what's common to us. What's common to us is the exponential graph. So we drew that first because it's easier for us to see it. As long as you can see this, you can then just use your line of symmetry to get the other sketch.
Yeah.
Perfect.
Okay.
Yeah, bo. Yeah, bo.